Isn't it 7 on 1? Then you pull out 7 on 1.
Now, yesterday I talked about differentiation. So today we're going to look at integration. On Monday, what we'll be doing is I'm going to put integration and derivation together, and then we'll do some problem solving. Alright? I was actually going to do some problem solving today, then I thought, nah, I'll just combine both into one lesson. I think that's more,
you're so good, bro.
a little bit more
He's got a spotter.
easier, I think, in that sense. But anyway, let's talk about integration.
It's fun, different.
Alright, let's focus, please. So the main two objectives today, what we're going to learn is integrating a over x, and then recognize the relationship with the natural logarithm.
Speed run the spread.
And then we'll talk about using the natural logarithm to integrate function of the form k times the derivative of fx over fx. Alright? Don't think it's as what I want all of you to do is basically focus on looking at what is the derivative of the denominator, and then look at what is the numerator. Few things that you need to recognize. Alright? So, recall when we did the power rule. When does the power rule not work?
When n is minus 1.
Thank you. When n is minus 1. So when n is minus 1, what do we get?
Divide by 0.
Divide by 0, and therefore it doesn't work. But now, on the other hand, if you think about dx of natural log of x, what do we get? 1 over x, which is x equals to x to the power of minus 1. So, power rule doesn't work. But when you integrate x to the power of minus 1, what do you get? The conclusion would be, therefore, for x greater than 0, the integration of 1 over x dx is natural log of x plus c. Alright? Now, the next thing you need to think about is, what if I've got something like ax plus b, a log of ax plus b? Recognize that the fact that this bit here, the numerator, is actually the first derivative of ax plus b, which is a. So if you see something like a over ax plus b, that is, if you integrate that, that would be the log of ax plus b. I'll close the door so that it's warmer in here. Alright? So those two things you need to know. I think, let me see what is in your formula sheet. I can't remember. Formula sheet, you don't have this. You have this. Formula sheet, you've got this one, for sure. This one is in your formula sheet, but not this one. This is in your formula sheet. Alright? But then, the next bit that I'm going to show you, you don't even need to remember this. Alright? Let's try example 1. So the first one, pretty straightforward. What you need to do is take the coefficient out. So if you take the coefficient out, all you need to do is integrate 1 over x. It's 3 over 2 times the integration of 1 over x dx, which means is 3 over 2 natural log of x plus c. Now, remember your plus c. Alright? Quite a few of you lose a mark because of notation. Remember your notation. It's so important. Alright? So the next one, again, take the 7 out. It's 7 times the integration of 1 over x minus 1. So therefore is 7 log of x minus 1 plus c. Natural log of x minus 1 plus c. Now finally, recognizing the third one, the derivative of 2x plus 5 is 2. So you need to have a 2 here. So therefore, you can have 5 times the integration of 2 over 2x plus 5. That is, the numerator is the first derivative of 2x plus 5, the denominator. So therefore, it's 5 times log of 2x plus 5. Alright? Happy with that? Pretty straightforward. The first bit is pretty straightforward. It's always pretty straightforward. Wait until you get it a little bit later. Now, generalization. It is important to identify the need for the natural logarithm when there's a visible differential relationship between the numerator and the denominator of the integrand. So for any fx greater than 0, if you are integrating a fraction, so if you look at the numerator, if the numerator is the first derivative of the denominator, then that automatically becomes natural log of fx plus c. Alright? So that is in your formula sheet. But you should be familiar with it after you do a few exercises. Alright? You should be able to get used to that.
Just sit there for half an hour.
Let's have a look at this one. Here, when you take the first derivative of x squared plus 5, what is it? It's 2x. So therefore, this is 3 times 2x. Yeah? So if you know that that's 3 times 2x, you could actually rewrite this as 3 times the integral of 2x over x squared plus 5 dx. Since the numerator is the first derivative of the denominator, therefore the answer is 3 times log of x squared plus 5 plus c.
Yep.
Alright? Now,
Half.
this one, thank you, half. Because you need 2x plus 6. So therefore you need a half. Once you could recognize that, it's half of log of x squared plus 6x plus 1 and then plus c. Alright?
Mm-hmm.
We'll slowly get into the more and more difficult examples. Alright, now, example 3.
Should have used it all the time.
Here, you need to determine the definite integral. And you need to give it as the exact values. In this case, you know that this is actually the negative of the derivative of that, correct? So you need to put a negative up there to the and you can work this out. Negative of negative 3x squared divided by 2 minus x cubed. Alright? And therefore, definite integral, write it out this way. Make sure that you get the convention right. So the first one is 2 minus log of 1 and minus log of 2. Alright, write it with your bracket so that you know eventually it will become log 2 take away log 1, which is just log 2. Alright? You must recognize how to simplify that. So, negative times negative, that's positive. Positive take away 1. And it's 2 divided by 1, so it's log 2. Alright, can you try this question, please? I'm going to keep my mouth shut for a while. Example 3.
It's not 3 on 2.
Because what is log 1? What do you have to raise to the power of b to get 1?
Alright.
Sure. e to the power of 1 is e. Yeah, 0.
Wait, is it
Alright,
1 is
so
0.
Is it
what is
23
ddx of sine 3x?
2 and 3.
What is ddx of sine 3x? You need to recognize that first.
Is it 2?
ddx of sine 3x.
Oh, yeah.
is 3 cos 3x. Alright? But this is 2. What are you going to do with that?
2 and 3.
Thank you. 2 and 3.
Ln of pi and 4.
So you need to be really well versed in your differentiation, and also your how you derive your trig function. First step will be rewriting that. So now, if you rewrite that, you know that the numerator is actually, you obtain the numerator by differentiating the denominator. And of course, it will become something like this. Agree?
Yeah.
Okay, next, how are you going to find the integral? Exactly. You need the exact value.
Whoa. Is right. It is
2
right.
and 3, and then root 2 and 2.
Possible answer?
Possibly.
What do you mean, sir?
Oh, you probably simplified it or something.
No, yeah.
Yeah.
All right. Now, my suggestion is
Because you can make it to the
you keep your 2/3 outside the bracket first. Evaluate this first before you do anything. So if you evaluate, sine of 3 pi over 4 is 1 of square root of 2.
Oh, because you can get rid of the.
Sine of pi over 2 is 1, so therefore it's log 1.
Rid of
So
the
2/3 log 1 over square root of 2, take away log 1. So what is log 1?
This is 2 and 4.
What is natural log of 1?
Zero.
0.
LA,
So
2 and 4.
you've got 2/3 log of 1 over square root of 2. Now I'm going to play around with it. I mean, this is the answer, but I could actually rewrite it as 1/3 to the power of that.
I did that one.
Yeah? And then think about that. That will be 1/3 log of half. And then half is
Did you doubt though?
minus 2 to the power of minus 1.
And
So it's therefore
cube root.
negative 1/3 log 2.
Oh,
Alright?
okay.
Now,
I didn't do that one.
it really doesn't matter if you give me this answer, or that answer. But if you use your class pad
That is very
to integrate that, class pad will give you that minus 1/3 log of 2.
The game is worth true.
Oh, this one's just
You should flip, like, make it negative.
Sorry?
yeah.
With a negative 1/3 is like a power.
Yeah.
Okay, so what I've done is I changed the 2 half into 2 to the power of minus half. Minus 1, 2 to the power of minus 1. So I take the minus 1 out, it became minus
No, you
1/3.
just do power rule. Am I doing that?
Alright.
Is that even?
So I
guess.
see what I've done here.
Yeah.
I have actually changed the half to 2 to the power of minus 1. And then by using log law, minus 1, I can actually bring the power out. Therefore it became minus 1/3 log of 2. I mean, there are many ways of writing this answer anyway. So there's no really hard and fast rule. If you give me 2/3
Right.
square root of 2 over 2, that's fine as well.
I got to be thorough.
It's just that I was playing around with it, showing you the few different possible answers. Alright? Next, you need to determine a particular solution.
Yeah.
Now, you need to note what is dy dx of E?
0.
0. E is just a constant. So here, I actually want you to note that if I do a d dx of x squared plus 2x plus e, because e is just a constant, to differentiate x squared plus 2x plus e, the answer is 2x plus 2. Alright? And how do you link that to this? You got 4x plus
You just
4.
pull out the 2 times.
Thank you. You pull out the 2. So if you pull out the 2, this is what you get. Again, remember E is just a number. Nothing special about it. E is just a number.
I'm gonna juggle this piece.
Alright, once you've done that, you know that that's actually
X
2 times log
What? That doesn't
of
make sense.
x squared plus 2x plus e plus
How's 5
c.
equal to 2?
So to find a particular solution, you need to actually evaluate
C.
y equals to that by substituting
5 plus C.
5 and minus 2 in so that you can find your c.
It's 3.
Alright? So when we're x equals to minus 2, y equals to 5, substitute everything in. So therefore, you know 5 equals to 2
Plus 3.
times log of 4 minus 4 plus e. 4 minus 4 is
1.
0. So what is log of e?
1.
1. And therefore, you know c is
3.
3. And this is your equation.
Yep.
Alright?
That is my equation.
Oh, yeah,
They left this behind.
This piece was a. This piece is.
Wait, that's light work, bro.
Bro, you gotta juggle this like. Juggle these.
Juggle these. Nah, you don't have to juggle, you can just.
What, factorize?
Alright. Now,
Can't do that,
the
right?
next one is interesting.
Yeah, you can't.
Ignore that first.
Yeah, I guess you do have to.
Alright, you've got a graph.
Yep.
fx is 1 over x and gx is 2x over x squared plus 1. Alright?
Do that first.
You need to find,
Huh?
I don't think you can do that.
you need to actually show that the intersection between the
Okay,
two
it's
graphs
plus
is
5.
1.
Plus X.
Alright?
Mate, it's 2
Now.
turns on 2 turns.
Note that in this situation
Times,
here,
yeah.
No,
Alright.
like,
I have
Oh, yeah,
not
no,
plotted
no,
the
yeah,
fx 1 over x, fx equals 1 over x in the third quadrant. I'm looking at the first quadrant only. I'm not looking at the third quadrant.
It's gotta be what?
So when you solve it, you've got to make sure that you know which
partial fraction.
which number of x, which x you should use.
Wait, go on.
You should know, you should think about what is the x value. Alright? You need to look at the graph. You need to determine what x is. Because if you actually plot fx equal 1 over x, you could potentially get 2 values.
Yeah, okay.
So, to actually show that the two curves intersect at 1, 1, you need to equate those two, correct?
Yeah.
So equating those two, you will have 2x squared equals to x squared plus 1. So x squared equals to 1, x equals to plus or minus 1. So you have to reject x equals to minus 1. It's important to know that rejecting x equals to minus 1. And then substituting into either fx or gx, I substituted in both. So therefore the point of intersection is 1, 1, not 1, 0. I'll correct that later. It's 1, 1. Should be 1, 1. Right. Now, you should know how to integrate the final area. So this bit here, split into 2 bits. You know the intersection point. You know you want to go from 0.5 to 2, right? So, between 0.5 and 1 is 1 over x take away 2x over x squared plus 1. And then from 1 to 2 is 2x. Take away x squared plus 1. 2x over x squared plus 1, take away 1 over x. So write those down. 2 parts. You want the area under the curve. Remember, this is not the signed area. This is not the signed area. It's all positive. Alright? One take away the other.
And then 25 and 16.
I think so.
Can't remember.
What are you?
Alright.
Huh?
So you should have log of x take away log of x squared plus 1 because 2x, that is the, if I derive x squared plus 1, I get 2x. So that's, you can straight away see that that is log and log. And then substitute the values in. Now, before I substitute the value, I actually rearrange this using log laws to have x over x squared plus 1. It will make life easier for you. Alright? So that when you substitute in 1, you got one value. Substitute 0.5 in, that's 1 value. And then that one, using your log law, is x squared plus 1 divided by x. Again, you will only have 4 values to play with, rather than 8 values. Alright? Use the log laws to your advantage. You don't want to be dealing with so many values. You only want to deal with about, in this case, 4 values. It will make simplifying a lot easier in that sense.
So isn't So isn't this supposed to be
Sorry?
Isn't this supposed to be a 2x? Isn't it supposed to be 2x squared plus 1?
2x squared plus 1? No. What would be?
Oh no, yeah.
No,
Never mind.
x squared. Well,
I was reading something.
okay, that's alright. Alright, so once you've got that, now, put everything in this perspective. So I've got half 2 over 5, 5 over 2, and log 2. It makes life a little bit more straightforward if you've got everything in the fraction in this case, because I haven't asked you to use a calculator. I'll assume that this is calculator free. It will be a typical calculator free question because the numbers are pretty straightforward. Well, you got a half, you got a 2 over 5, you got 5 over 2, you got a 2. A lot of these questions are manufactured anyway, so that we get the right numbers.
What'd you get?
Especially the
25,
calc free section. Alright, so therefore you've got log of half.
Yeah, why'd you just...
Now, take away log of 2 over 5. So therefore it's times 5 over 2. Right? Because it's divide.
So then
Yeah?
they're all
So it's
fine.
divide, so I
That's 1
times
on 2 times 5 on 2
reciprocal of that. And then plus is times. And then
Nah, but you didn't, because you did
minus is
Divided by.
is divide. So you take a reciprocal of 2.
you just did
So you ended up with log of 1 over 16 and log of 25. Now, the reason I do this is I want to make it a little bit neater in a way. Here, you actually have 25 over 16. Alright? 25 over 16. So therefore, this is log of 25 plus log of 1 over 16. Or you can do log of 25 minus log of 16. It's fine. Either way is fine. Once you've got that, you can see that this is log of 5 square, take away log of 4 square, which means it's 2 log of 5, take away
That's 1 and 4, right?
2 log of 4.
5 and 4.
Ooh,
Alright.
he went up to you, bro.
And then 2 on 5.
He went up to you, bro.
2 log of 4, or actually,
It's equal
my
to
own
2.
answer is 4 log of 2 because this is 2 to the power of
He
4.
went up to you, bro.
Now, no reason why if you give me 2 log of 4 is wrong. It's the same thing anyway. Alright?
So could we leave it as log 1016 plus log 10?
Oh yeah, I think so. I'm not worried about that. Because it didn't ask you for the most simplified thing. I showed you is because it's
It was
possible
like
to do that, that's all. If you give the answer as log of 25 over 16, there's nothing wrong with it. Yeah, agree?
Times it.
Yeah. It's just that normally when we write log, we don't write a fraction, but
Yeah.
they cannot penalize you with this answer. That is the correct answer as well. Alright, now, question like this. Alright, let's focus. How would you tackle the first
Split.
integral? Integral.
Split it.
Split it. Very good. So, when situation like this, this is not, you cannot,
Yeah.
the numerator is not the derivative of the denominator, and you know that there's only one term in the denominator, so you split it. Alright? Split that. You therefore have got 4x squared divided by 2x cubed, x to the power of 5 divided by 2x cubed, take away 2x divided by 2x cubed. Alright? Split it. Once you split it, you can simplify before you take your integration. Split. So you therefore have 2 over x plus 4x squared minus 1 over x
You're
squared.
completely wrong.
I did it correctly.
Alright.
I just didn't do this.
So that is your log. That's not. You can use your power rule for that. And use your log for the first one. 2 over x. I mean, really, to be pedantic, I should have put a bracket over there. But when I wrote it, I did not. Alright? So this is the only log. The other two, you use power rule.
Yep.
Power rule. And this is log. Alright?
The gang is what on drugs.
Make sense?
Yeah.
And then that's your answer. Now, what about the next one?
Algebraic juggling.
Sorry? Algebraic juggling, okay. What do you mean by algebraic juggling?
You just algebraic juggle.
You just like
What would you
I don't
do?
even know how to use
So-
factorize x,
Yeah?
x and then x minus 3, and then you plus x plus 5, and then you can just cancel the
Can you?
x. Yeah. I think
Can
so.
you? Or, now, can you remember your algebraic division? To find the, you see,
But it's the same.
you cannot
It's just a
factorize
different
this, correct?
It's just a different way.
You can't factorize this.
Yeah.
So you cannot factorize the numerator. So polynomial division. Do your polynomial division. Alright, back to year 11 work, polynomial division, and find the remainder.
Yeah, you got it wrong.
X minus 3 is not,
Because it's x plus 1.
X minus 3 is not a factor of x squared minus 2x plus 5. And you
Because
cannot,
you can do 1.
you cannot
This x, so it gives you negative
factorize
3x.
x squared minus 2x
And you want
plus 5.
negative 2x, so it's times it by 1, x take 3.
Alright? So I'm not going to go through polynomial division, but I hope that you remember from year 11.
X take 3. That's what it is.
So you can see that methods
just
course
add
is
on
really
x
good from year 11 to year 12.
So you can
It
cancel
actually everything links together.
So then it's
No, you can still do this.
So if you
Yeah.
do your polynomial division, you know that
take
there is a
all.
remainder of 8. That will be,
X plus
you can rewrite the whole
plus
integral
x to-
as this. X plus 1, which is that, and then remainder of 8 over x minus 3. Yeah? You can split that into that. This bit into here. Make sure that you know your polynomial division. Alright? This is a hard example. It's a really difficult example because it's, unless you really think about polynomial division,
makes sense.
it took me a few minutes to figure out what I should do with this as well.
You just use
Alright?
the same thing.
Oh, I think that, yeah, it should be.
Because 3 ln of x.
Do your polynomial division,
Yeah, it's fine. It's the
then
same.
you can
Oh, no,
actually
'cause
just
this should be x
think
times 3.
about integrating this. Alright?
Wait,
So therefore integrating this is x squared over 2. 1 is x.
Yeah.
This
You
is
just
8
make-
times
you just miss an
log of
eight.
x minus 3 plus c. The difficult bit is recognizing that you have to do the polynomial division.
Usually,
plus 3,
Yeah?
and x minus 3.
Alright?
So you get 1 here.
Hope you recall all your polynomial division.
1 plus 3 on x minus 3. X minus 3.
yeah, that's what you missed. And then,
Yeah,
so this
yeah,
is x minus 3, so
Yeah,
then you
yeah,
can
yeah.
Alright,
put
happy
these
with
together
it?
and it's
Yeah,
fine,
yeah.
which is the same thing as 1.
Okay.
Yeah, see, look. Yeah, that's what he did. It's
Alright.
Plus 8.
Yeah.
Example 7. It would be a possible exam question, this one. This is a possible exam question.
Yeah, methods kids can do this. If it's scaffolded, yeah.
It's partial fraction.
So this is potential exam question. So given that x plus 2 divided by x minus 1 times x minus 2 equals a over x plus 1 plus b over x minus 2, when a and b are constants, you need to determine the values of a and b and then find the derivative of x plus 2 divided by x plus 1 times x minus 2. You know why? You need to think about splitting this into that because you can integrate this and integrate that.
Yeah.
So how do you work out what A is, what B is? Alright?
I've already forgotten.
What is the first step you would do? I'm actually going to look at the right hand side first. Ignore the left hand side, look at the right hand side first.
Oh, ax take 2 plus
So
b x plus 1 is equal.
A over x
Yeah.
plus 1 plus b over x minus 2. So I merge them together. If I merge them together, you can see that this bit resembles that already. Alright? Now I can work out what A and B is. I can work out where A and B is. Which means what I need to do is expand this. Once I expanded the numerator, I'm going to group as in the x together and the constant together. Alright? So you group the x and the constant together,
What you get for your thing?
and you therefore have a plus b times x plus b minus 2a. Now, if you look at this, your a plus b times x is actually your coefficient of x, which is 1x. And then b minus 2a,
You get a is equal to minus 1 and 3.
b
Yeah.
minus 2a is actually 2. So can you solve for a and b now?
Yes.
Using simultaneous equation. Alright? So you know a plus b is 1, b minus 2a is 2. Definitely potential exam question.
It's a good one.
Because he's just collecting the constants and the x terms together. Because there it's ax minus 2a.
So if I'm correct, A equals to minus 1/3, B equals to 4/3.
Yeah.
All right. This will be a potential, I think it will be a potential calc-free question. Right. Now, of course, x cannot be minus 1 and x cannot be 2. All right, the denominator has to be greater than 0. All right. So therefore, integrating that. Now,
Facts no capture.
does that make sense?
Yeah.
That's one.
So you can see that it makes life a lot easier now, because that will become, you know that that's, if you take the first derivative of x plus 1, you got 1. First derivative of x minus 2, that's 1. So, it's just minus 1/3 log of x plus 1 and 4/3 log of x minus 2 plus c. Now the tricky bit for this is not the integration, it's this step.
Yeah.
This step is the tricky bit. If you don't recognize this step, you can't do that at all. Alright? I mean, in exam itself, they may ask you to prove that A is 1/3 and B is 4/3, and then you can
What do you mean
do
different way?
part B, which is integrate that. Alright? That will make life a little bit easier
Adjust the
in the exam.
Oh yeah,
But I don't know
It doesn't matter. Doesn't matter.
what will happen in the
Also, you
exam.
can make this step a lot quicker. You substitute 2 in
Alright, a little bit more to go, about 5 minutes.
You get 0 plus 3b
Now,
equals 4.
What happens if 1/x is less than 0?
And then for b, you can just sub in -1.
Alright?
Did you do that?
Yeah. And you-
Let's focus
take
on this for a little
Yeah.
few minutes. Alright, just need to get
Something's
through to you. I don't think it's really in the syllabus, but I need you to all understand this. So I can rewrite 1/x as minus 1/minus x, correct? So therefore, we know that
1 minus a minus 2
that
is
uh,
1 minus
the two integrals are therefore equivalent, since minus 1 divided by 1 equals to 1. Alright? So therefore, integrating minus 1/minus x, we've got log of minus x plus c. Alright, this is information for you to know. And what happened is, when we plot the two functions, this is log of x, and this is log of minus x. Alright? Which is the reflection about the y axis, or x equals to 0. Now, recall what we do. The function is the absolute function.
1 minus
Alright?
a
So everything is positive, it's absolute
minus
function.
2
These two functions made up
negative
log
3
of absolute value of x. And think about the gradient. Think about the gradient at each point. So here, as x approach infinity, look at the positive part. As x approach infinity, alright, dy dx approaches 0. Alright, as x approaches 0 positive, dy dx approaches infinity. So you can see that this bit here is 1/x. Right? Whereas this bit here is minus this part of the 1/x.
Yeah.
Alright? So, therefore, integrating 1/x, it's log absolute value of x plus c, as long as x is not 0. But in fact, you will not be penalized for not using the absolute value in 12 methods. Alright? So, this is just extra information for all of you to know. Yeah?
Yeah.
Alright, I'm going to stop here. I've given you some questions from, I think, Nelson and Sadler to do.